Each workshop, I mean, each peer leader does go over their respective workshop, their students. We go over your videos we watch just to make sure there's no suspicious activity. I hope we go over this enough where nobody has any doubts and nobody has any temptations to try to cheat, but that's the whole point of the lockdown browser. Just want to avoid all of that. So yeah, make sure everything around you is off, no headphones. Yeah, okay. Is it automatic? Are there going to be any temperature conversion questions? Are there?
We'll say yes.
Yes.
Yeah, I'm gonna say yes.
Even then,
just because I'm just gonna say yes. But there's an easy way to memorize them.
Yeah, and I'd say yes anyways, because you're gonna need to know them eventually anyways. You're gonna for sure know how to. Like I told my workshop today, you're gonna need to know at least for sure Celsius to Kelvin and Kelvin to Celsius. That's the most common one you'll see throughout the semester. But I mean, never say never that they won't give you maybe a Fahrenheit to Celsius or Celsius to Fahrenheit. Just make sure you got those down anyways, even if you don't get tested on them. Oh, that's fine. You could just for sure tell the camera's recording you. It has noise. Just make sure if there's anything like that, explain what the noise is to the camera, and we'll go over it and we'll see there, and we won't flag it as cheating. Yeah, just make sure if there's any. I understand. Yeah, since we're home and there's family thing, pets, anything that can make a lot of noise, and you got to move. For sure, try to not leave the camera, like not leave your seat. But explain the noise and we'll excuse it.
Yeah, and then also remember, we are recording you and we do not hesitate to fail you if you guys are caught cheating.
So. I don't want to, but we will.
Try explaining that 0. Okay, cool. Should we start on content then, now that we have?
What are we allowed to have on our desk? Like just a pen and paper?
Pen, paper,
yes.
Oh, your ID. Make sure you have your ID because I'm going to ask for that too. Your school ID. Does it still ask for that?
Yes, it does.
Yeah. Okay.
Yeah, your school ID, and also if you don't feel comfortable like me using a periodic table as a link, you can have your own one. Just make sure to show it and make like front and back so we can know you're not cheating as well. You know, because I don't like using online periodic tables. So if you prefer using an actual one, just show the thing front and back, and that'd be fine.
And then conversion tables you cannot have.
Yeah, conversion tables you cannot have. Just a periodic table.
You are allowed, Luis. You asked. You are allowed to use calculators. Just make sure it's not programmable. For those of you who don't have your ID, I don't think it's necessarily school ID. I think you can show maybe your license. Just any form of identification.
And if you guys happen to not have a license or anything like that, a high school ID, just something with your picture and your name so we can prove that it is you.
Yes, exactly.
Or a passport, that too.
But you guys should, well, when I took Chem 1, I needed lockdown browser for the lab portion. So I'm pretty sure you guys are already somewhat familiar with that.
Yeah, lecture yesterday, I saw there was a lot of confusion as to why you lockdown. And some you're gonna need it for maybe not like even if it wasn't this class, you're gonna need it for a class eventually. So you do need lockdown browser anyway. That's the main way to avoid cheating because I understand like as a student and like I've seen it's a lot easier now and it's a lot harder for us as instructors to keep track of how you guys are turning in your work, how you guys are doing it. So we do require lockdown browser. I know Dr. Alexander stated, and I know he kind of he's giving a little confusing answers to questions, but just make sure because I know he was referencing, I assume everybody got the Lester, that's our head peer leader. He's the one that kind of takes care of everything, the making the tests and the and providing it for Dr. Alexander, because you can see he kind of has a little trouble with technology sometimes. So that's why for some of the questions he kind of said, I don't know. Just rely on us. If we give any, we usually for sure already are up to date on everything. So all the information that we typed out should be up to date and reliable. If we made a mistake on. We'll for sure for next time avoid that. But there shouldn't have been any mistakes in it yesterday. But yeah, you do need multiple compounds.
Well, are there any other questions about how the test is going to be run?
I see a lot of them are asking like memorizing stuff. Yes, I do encourage you to memorize everything. Try to. For sure, your rule of 7 and all your polyatomic oxide ions you do need to remember, because that's like exactly the same as like temperature. The temperature conversions, you're gonna see those, all of those type of polyatomic ions always throughout the semester. You're for sure gonna see them, and you need to memorize them, because eventually that's how you can do problems faster. You already know the names of the elements and everything. So I do recommend memorizing everything. So for all of you who have questions like, should I memorize this, that? The answer is probably yes.
But not only memorize it, guys, it's really helpful that you learn it, that you
understand
the
why.
content 100%, because modules 1 and 2 pretty much set the base for the whole chemistry course. So everything you guys learned now, you guys are going to use the whole chemistry 1, and if you guys take chemistry 2, chem 2.
Yeah, she said. But yeah, so yeah, any about that, yeah, memorizing. I know that some of you had problems like there was some sort of compounds that you do need to memorize because they don't follow the naming, the rule naming that is stated in the workbook. Like let's say there's the ammonium, ammonia, acetate. Those are some that we'll write out right now, but those are some that don't follow necessarily the rules of that are stated in the workbook. But you need to memorize those because those don't have any specific like well, they do have their reasoning, but they don't follow the whole ionic compound rules, or like your alkanes also, like the CH4. You might have noticed. If you, hopefully everybody's read all the modules. Also that I hope nobody's coming in here blank, because that's what we don't encourage at all. This isn't a lecture. We're not supposed to lecture you guys. Our job and our goal is to just make sure you understand it, but nobody should be coming in here expecting us to teach you everything. Okay, so just I want to make.
We're not going to teach 3. We're not going to teach 3 weeks of work in like 2 hours.
Yeah, like hopefully you guys. Even then, also with your workshops, just try to read your modules every week before, and even if you don't understand it, it's better than going in. It's better going in at least reading it and not understanding it than not even looking at it at all. Because from then we have a starting point. At least we can like help you understand what you don't know yet. All right, but yeah.
Okay, cool. Let's get started with the material. And then if any questions come up, just type them out in the chat. So I think what we're going to start off with is naming ions and covalent compounds. So just naming stuff.
Do you want me?
Can you share? Yeah, I think I allowed you to share the screen. Yay!
All right, cool. Okay, so how this is going to work is I guess we're just going to ask you a couple questions. What type of compounds are there? There are, I guess, 2 that you saw in lecture. 2 types of compounds. What are they?
Ionic and molecule.
Okay. So ionic and covalent. You also call it molecular.
Molecular. Nice.
Right. Which one's which? How do you know between those 2?
Ionic is a metal and a non-metal, and then molecular is just non-metals.
Okay, cool.
What else?
Non-metal.
There's another way to know whether it's ionic or covalent. It has to do with the bonding.
If it's sharing electrons or if it's giving one away.
And which one's which?
Covalent shares and ionic takes one away.
Exactly. Exactly. Okay, and does everybody know their metals though? Does everybody know does everybody know their groups actually also? All right, so if you look at your periodic table, it should state already there like the group 1s, group 2s, and then your transition metals, and then group 3, 4, 5, 6, 7, and 8. Does everybody know what their metals are? So like besides their transition metals. Because that's also a lot. Just make sure group 1, if you can see, it starts with hydrogen, and then group 2 starts with beryllium. All of those except hydrogen are metals, all right? Make sure that the metals, and group 1 is called alkali metals and group 2 is alkali earth, all right? I don't know if that's a question on a test or anything, but it's good to know anyway. All right.
It'll come up on your final, I guarantee it.
Yeah, so yeah, just alkali, group 1 is alkali metals, group 2 is alkali earth, all right?
Okay.
But yeah. Oh,
All
so
right, so
yeah.
these ones are alkali, and then these ones are alkali earth.
Yeah. And then can you point out the transition also for them?
All these are transition metals.
And also, an important thing is also their charges. So that's what ions are. Ions, remember, ions, the definition is just a charged element. So it's element with a charge, all right? So that's basically what it is. And each element in a group has a particular charge. So we can explain later on why those charges are, because usually in lecture, which I kind of didn't like, is you just told what they are. Sometimes they don't explain it, like, so let's say group 1, their charge is always going to be +1. We'll explain right now as to why it is +1, but just so you guys know it is +1, and then group 2 is +2. Then you skip all your transition metals, and then it goes to +3, and then it's what, ±4, was it? Or like, yeah, ±4.
Plus minus 4.
And then -3, -2, -1, and 0 for the last group. So everybody should know at least those, like maybe in high school chem you went over that. Those are your noble gases. Those are always stable. That's why their charge is always 0. All right. Okay, so, and the 7th group, the one that starts with fluorine, those are your halogens. So you're all, you know, those halogens. All right. Halogens and noble gas to the right. All right. So what else?
We'll go back to this page. Okay, cool. Ionic, metal, non-metal. This one's takes and gives. Covalent is they share them. Let's see. We'll start off with the ionic ones first. Does anybody know the rules to naming ionic compounds? Just unmute your mic. It's easier than just talking.
Yeah, than typing
it out.
We appreciate it more if you just like open up your mic.
Well, for ionic it has a suffix of IDE.
Okay, we got "ide." There's another one.
We start off with the metal first and then the non-metal.
Okay, so metal, then non-metal, plus the "ide." And there's one last thing.
All charges must be equal to 0.
Okay, that's one. So net charge of 0. There's one, especially for something we call transition metal.
The Roman numeral?
Perfect. So Roman numerals. So that's your 1, 2, you get it. Okay, cool. So can anybody tell me what that is?
Sodium chloride.
Okay. Everybody agree?
Yes.
Quick question for you guys. When naming ionic compounds, do you use prefixes?
No, only covalent.
Yes, good job.
Perfect. What's that?
Iron 2 oxide with the Roman numeral 2.
Iron 2. oxide. Does everybody get where he got that from? And then
Yes.
Where did
Okay,
you get
if you-
the two from?
okay. So this is iron, right? And this is oxygen. So because of this rule, up here, you just drop it iron, oxide. You guys get that one, right?
Also, you
Yeah.
can tell them like the two, well, if they're asking like where they got the two from, just remember
Okay.
them as the ions. So like the iron ion and then exactly, yeah, the iron ion and then the oxide ion. So that's why. So I feel like in your book it tells you to switch, but like the whole cross switching. But also just think about it like it's not, just don't memorize it as that. Like if you want to understand it, it's just basically you're trying to get the charges to cancel out to zero. So if you have a charge of 2+ and a charge of -2, you only need one of each. Does that make sense to get a charge of 0? Okay, so like try to give them the example like a iron 3 oxide or something.
So here's a question like, why do you think for transition metals we have to put the Roman numerals? Why do we have to put the Roman numerals?
You have to specify like what type of that element is, like what charge it has.
Yes, because with the transition metals, they don't have a specific charge assigned to them. So that's why you always have to assign it. That way we know which one you're using. So that's the reason why we have to put those Roman numerals in transition metals. Just an explanation there.
Could you repeat that again?
Yes. So the reason we put Roman numerals with transition metals is because with transition metals, they don't have a designated charge. So we have to specify which charge it is by putting the Roman numeral.
Yeah, so in other words, just transition metals can have multiple charges.
Mhm.
That's why. Because if you see down right there at the left, it says Fe2O3, and then you see to the upper right, it says FeO. Those can technically both be called iron oxide. They're both called iron oxide. You just have to specify what the charge is.
Give me it. No, because I already
Did you do that, or did I cut off? Or?
No, I got it.
Okay, you guys got it? Yeah, that's why we specify, because technically two can be called iron oxide, so we have to specify what the charge is of the iron. But yeah, if you see also there in the iron 2 oxide, in the iron 3 oxide, which is the bottom left one, you see that we did do the switch, but also just think about it. If iron has a charge of 3 and oxygen has a charge of -2, to get them to equal out a 0, you need to multiply the 3 times 2 and the 2 times 3. So that's why you have 3 of the oxygens and 2 of the irons. Does that make sense also? Because if you multiply those out, they will give you 0. Yeah, thank you, Claudia, for writing that. That's basically what it's doing. But because there's been some confusion as to doing the switch, but that's basically what you're doing, just making
So
sure.
how would you name that? Would it just be iron oxide?
No, iron 3.
Iron 3 oxide?
Yeah, because the charge was 3, because you see the 3 down there in the oxygen, you see that it came from the charge of the iron. That's why you needed 3 oxygens to cancel out. So you assume from then on that it's iron 3 oxide. That makes sense?
What about the 2?
The
Well,
2 is the charge of oxygen.
Yeah, of course.
So it has the charge of 2. So you have to, you end up switching them. So the iron, you know that it's going to have the charge of 3 because subscript on the oxygen is 3. So, and you know that naturally oxygen has a charge of 2.
Yeah.
Okay, just to kind of reiterate what they're saying, there is a difference between these two. So this is tin 2 chloride versus this one's tin 4 chloride. And if we just put tin chloride, we wouldn't know which one we're talking about. So that's why we have to designate using the charge of this. That's the reason because of that. Does that make sense?
Because it can both be called tin chloride, but you don't know which tin. Yeah, it is basically. But yeah.
Are we all good on naming ionic compounds?
Yes.
Yes.
Okay. Let me just clear that. Okay. So next is, if it's not ionic, then it's covalent or molecular.
There you go, Jonathan.
Covalent or molecular. So what is that?
Carbon dioxide.
Perfect. So let's talk about the rules of naming molecular. So what are the 3 or 4 rules? I think they are.
If the first element is 1, you don't use mono.
Okay. I saw in the chat that they said prefixes.
Prefixes on which element? The first or the second one? On both.
Second.
Second.
Wrong on both of them.
Yeah, it'd be both, unless it has like it was mentioned with the first rule, like if the first element is 1, you don't use that prefix. But if you do have something else, then you are gonna have to, like H2O. There you go. Thank you, Jonathan.
And then there was one more in the chat. And in "ide." Is that correct? Yes, it is. Okay, perfect. So name that. We call that water, but what is its chemical name?
Dihydrogen oxide.
Okay, dihydrogen oxide. Perfect. So these molecular ones, pretty easy. Just remember your prefixes and remember your prefixes is
It would be dihydrogen monoxide. Guys.
Yeah, that's what I was gonna say. Yeah. Yeah. Remember the second one. If it has 1, it still gets the mono. The second element. The first one gets all of them except 1.
There you go. If it's the second element, you do use the mono. But if it's the first, you don't. Like CO2, like we did, carbon dioxide. You don't use that one.
We wouldn't call it monocarbon dioxide. Technically, it's not wrong, but we just choose to ignore it.
Yes.
Yeah. Yeah, for sure. The whole after that, the hopefully everybody's like knows the like Greek whole prefixes. Hopefully like that's how we used to do. Like it should be similar like from middle school or something when you do shapes or whatever, like a pentagon, an octagon,
hexagon,
all that stuff. Just remember, tri is 3 and tetra's 4. I've had some confusion where people think tetra's 3. Yeah, just make sure of that. And then penta, hexa, hepta, octa.
Nona, deca.
Yeah, nona, deca. Yeah, please make sure to memorize all of those. Hopefully it shouldn't be too much trouble. Like I said, they're kind of like not common sense, but you've heard of them before. Hopefully.
Can anybody name that? Actually, no, not that one.
No, oh yeah, I was gonna actually.
Can anybody name that?
Propane?
Yeah.
Propane.
All right.
Yes.
So,
perfect.
So propane. How did you get that? How did you assume? How did you get it was propane? For whoever answered it, just Okay, the C and an H. Okay, so I see someone said C and an H. So what does that mean? What does that mean? Just C and an H. Okay, I see the equation, but what are they called? Okay, someone already wrote it down. Never mind. Okay, those are alkanes. So yeah, just make sure alkane is just a carbon and a hydrogen atom together. Those don't usually follow not usually. They don't follow at all the naming rules because as you can see, they're both a nonmetal and non-metal, but they don't follow that whole naming. You wouldn't call it like tricarbon, octahydrogen, like all of that. They're called alkanes, so that's why you see the A and E at the end. So if you see something that has an A and E at the end, just remember it's an alkane, which probably means it's gonna be, like if someone were to tell you name pentane, if you see the ane, just remember it's an alkane, so you can assume right away from there that it's gonna have a C and an H, all right? And then the equation down there tells you how many hydrogens you have. So yeah, all of that. The prefixes tell you the prefixes tell you how many carbons you have. Just make sure that. Okay.
Yeah, so we got methane, ethane, propane, butane. For the first four, instead of mono, di, tri, tetra, we got methane, ethane, propane, butane, and a way to remember it is mama eats peanut butter. So mama eats peanut butter, and then it's the same thing, penta, hexa, hepta, all that. Right. You can see my little pentane molecule, heptane molecule.
So if I were to ask, can you write down hexane, anybody? Because I don't have control of the writing down. So if I were to ask you in your test, or someone asks you in your test, like it says what is hexane? How would you guys like assume where to start? Where would you start in trying to figure out what the name of that, what the formula of that is?
Well, first,
We figure out the carbons, right?
I'm sorry?
The carbons?
Well, yeah, okay, yeah. And how do you know there's carbons in that for sure, though?
Well, because it ends with ane.
And that means what? That it's a what?
It's an alkane.
Exactly, yeah. So yeah, if it has an ane, it means it's an alkane, and if it's an alkane, it means it has a C and an H. And so let's look at another part of the word. It has hex. Does anybody know what number that is? 6, yeah.
Yeah.
And remember that the prefix or that first part of the word represents how many carbons there are. So we already know we have a carbon and a hydrogen because it's an alkane. And we know we're going to have 6, so we can already write down C6H, and then we still need to figure out how many H's we have. So can anybody tell me how many? Yeah. And yeah, you would multiply times 2, and then yeah, add 2 to it. So that's how you get your alkanes.
How do we get the hydrogens?
The formula right there, the formula is just you multiply the number of carbons times 2, and then you add 2. So 6 times 2, 12, plus 2, 14. Okay?
Yeah.
Yeah, all right. So I feel like everybody's got like, alkanes. You think, does everybody have a question on alkanes, on how to name them? Any still?
So it's double a carbon plus 2.
Yeah. Yeah, and remember, you get the number of carbons from the first part of the word of the alkane. Yeah.
Yeah.
Okay.
Okay, so moving on. Can anybody tell me what that is?
Oh.
Yeah.
Oh gosh, darn it. I forgot I'm the host, so I could delete all drawings. But it's okay, it's okay.
All right, yeah. Can anybody guess what that is?
Is sulfur dioxide?
Okay. Ooh, we got a sulfur dioxide and sulfite.
Ooh, okay. Ooh, okay.
Which one's
Can
right?
anybody say, yeah, which Yeah.
It's dioxide because sulfite would have a charge since it's a polyatomic ion if it was a sulfite.
Yes, that is correct.
All right, so yeah, make sure. And actually, I don't know. What's the difference between those? Why is what does it charge mean?
It
What
would
does that
actually be.
Anybody tell me? It's an ion, yeah. So what's SO2 then? Because SO2 doesn't have a. So what's that? What's the difference? Covalent, exactly, yeah. And it's a compound for starters. So everybody, for sure, don't think of the SO2 -2. Think of it. I like to tell my workshop. Think of it as one thing. It's an ion in itself, in a way. So we don't necessarily call it a compound. It is not a compound. We usually count it as a one thing. Okay, it's an ion. It's a polyatomic ion. Okay.
So if it has a charge up there, that means it's ionic, and if it doesn't, that's covalent.
Yes.
Wait, no.
Wait, what
If
did
it's
she?
if it has a charge, that means it's it has a charge. If it doesn't have a charge, then that means the protons and electrons are equal on that one. So remember that ionic is typically reserved for metals and nonmetals in this case. So remember that when we say the word ionic, it's like sodium chloride, what is it, potassium chloride, that type of stuff.
In their book, ions, though, the whole polyatomic, though.
Oh, it's because it's a polyatomic ion.
Okay, yeah, it is an ion, but it's
just
a
kidding.
Yeah,
it's a polyatomic.
Yeah, they're right.
ion.
They're right.
Yeah.
Oh yeah. So remember that. No, they are ions. They're just. It's because what people confuse is yes. Can anybody write sulfite with the actual sulfite? Because SO2 isn't sulfite.
It's hyposulfite. Yeah, it's this one. This is sulfite.
That's sulfite. So I know there are components in there that would make you think it's a covalent. There are, like, I think Dr. Alexander said this in the lecture, but there are like covalent bond compounds in that thing, but it's not, we don't consider it a compound at all because of the charge, okay? It's an ion. All right, because what determines a compound is like Jonathan said earlier, yeah, the charges do have to be canceled out. And here, as you can see, there is a charge, but like I said, try to think of that sulfite thing as one thing. It's an ion. It's a polyatomic ion, but don't think of it as two separate things. Don't think of it as a compound, which a compound is combining two separate different things, you know? I don't know if that confuses it more, but just, yeah.
When do you use the 8 ending? Oh, should we move on to polyatomics?
I got this. Yeah.
Should we move on to polyatomics? Okay, we're gonna move on to polyatomics. So how do you differentiate sulfur dioxide from hyposulfite? Again, it's with the charge, if it has a charge.
Yeah, let's go over the polyatomic ions first instead and actually see from then on. Yeah, let's cover that first and then ask if you still have that same question, let us know. But let's go over polyatomic ions.
Oh, I did something wrong. There you go. Oh, I thought Jonathan said that wasn't the case. Oh.
Yeah, that was a mix up a little bit. If it has a charge,
I made a mistake.
Yeah, if it has a charge, it is an ion. So, okay, so polyatomic ions. Okay, so so in your book you can see that they give you polyatomic ions, and then they give you the polyatomic oxo anion. So can anybody give me a polyatomic ion that is not an oxo anion? The common one that you're going to see throughout the semester, but think about it. The polyatomic ion that does not have oxo anions.
Remember, the oxo comes from oxygen, so it's just an polyatomic.
Yeah. So, okay, so if anybody could write it down, ammonia. It's ammonium. Ammonium. Yeah, NH4 plus. Yeah, that is a polyatomic ion. That is not an oxo anion. So that's one you're gonna see. It's called ammonium. I think Dr. Alexander went over it. Because if you notice all of these salts and metals and then IUM, indicating that they're like that's the whole charge explanation. So that's kind of why the whole reasoning behind the ammonium, just to like, I don't know how he said it, I forgot how he said it, but it was like just to establish NH4 plus as an ion. But yeah,
Well, think about it this way. Oh,
yeah, don't confuse them. Yeah,
think about it this way. You can buy ammonia at the store. You can't buy ammonium. So when you use cleaning products, then you'll see you use ammonia. You don't use ammonium. So if you can put it in a bottle, then that means it doesn't have a charge.
Yeah, exactly. So yeah, and just and one of these is an ion one with the, and remember an ion is just a charged a compound or element that has a charge, so it is an ion. And the other one does not have a charge, meaning that it's already stable, so it is a compound. Okay.
When dealing with charges, guys, which one is positively charged, an anion or a cation?
Cation.
Cation.
And just the way I like to remember it, cation, just remember there's a big T there, so that kind of looks like a plus sign. So yeah, just remember, and then anion, you're just like, that's not a cation, so it's negative. So yeah.
It has anion, the N is for negative.
Cats are positive. Yeah, that's a funny. Yeah, that's a good. They're positive. Yeah, cats are positive. That's one way to remember it.
That's cute. I like it.
Yeah. Just remember there's a big plus in there, so it's a positive.
Make sure
remember,
this one for sure.
Yeah.
And then so let's go into so that ammonium is a polyatomic ion. Okay. So now, can anybody give me a polyatomic oxoanion, which is the one that they cover most in the workbook? Anybody just type out or say an example of a polyatomic oxoanion? Sulfate, yeah, exactly. Okay, so sulfate is a polyatomic oxoanion. So if one of you guys can write down like the whole, well, no, not the whole word. I mean, I don't know if it's too much trouble, but basically the wording, it just defines itself right there. Anions are negatively charged ions. So it's many atoms containing an oxygen with a negative charge, all right? If that makes sense. So yeah, and that is all defined by the suffix ate. Okay, so if you see ate or ite, just know that there's going to be an oxygen. Okay. But then
Can I transfer to the periodic table?
Yeah, go for it.
Okay, basically this is how you. Oh, I think you can annotate on top of it.
Yeah, right. Yeah. Look. Let's see. Here. Yes.
I will give more examples right now. Give me 1 second.
Want to highlight? There you go.
So right here is your. Oh my god. Okay. Right here is your rule of 7. Oh, my hand is like so shaky. Okay. This is your rule of 7. You can use different ways to remember that. I mean, it looks like a 7. These whole things, like right here, it looks like a 7, but even then, there's like 7 of them in there. So you don't count. Yeah, you don't count fluorine or oxygen because they can't form an they can't form a polyatomic anion. Periodic table are we going to use? Like I said, it's going to be provided, so I don't know how the ones that Dr. Alexander provides are going to look, but if he doesn't provide one, I think the one that's in the back of your book should be just fine.
For sure, they're not going to have the names on it. It's just going to look like this one. It's just going to have the atomic number and the mass of each one, but they're not going to have the name, so you have to know like which symbol corresponds to which one, to which name.
So as you can see, there's 7 of them. If you count them, there's B, C, N, C, L, B, R, I, and A, T. Okay, so that's 7, and it looks like a 7, so that's why it's called the rule of 7. So all of these, what that is, just those 7s to be called to have the suffix ate, they need to have 3 oxygens. Okay. And then those 4 that were just circled in squared in red, they need 4. So think about it. Those 4 of them only 4 oxygens. Okay, so that's, you could like call, I don't know what you can call it. There's no really name for that rule, but it's just those little 4 need 4 oxygens. That's how I kind of memorized it. But yeah, think about it like I don't know if this analogy works. I did it for my workshop earlier today. But just think about them. This is like the reference. Yeah, the reference, the base, like the one that you'll see that needs to have to be called to that. You know what I mean? So all of those 7 need 3 to be called 8. Okay? And the 4 there need 4 to be called 8. Okay?
All right, I'm going back to whiteboard.
Yeah.
For
I is not for 2 oxygens. Well, it's just technically, more specifically, it's one less oxygen, not 2, because like if you had O2 for that little rule of 4 right there, for those in red, if you had 2, they wouldn't be just called "ite." They would have the suffix "ite," but they wouldn't have. They would have a prefix before them. Okay, so just think about "ite" means that they've lost 1. Okay.
And
yeah, "ite" means that they've lost 1.
They lost 2.
Yeah, so yeah, when you're going, and then when you're, so I is to let whoever know that you've lost 1. But let's say you're trying to lose another one, well, you can't call it "ite" anymore. You can't have the suffix "ite," but you need to have something else. Because let's say you had sulfate, how we had right now, which was SO4 -2. If you wanted to say that it's lost an oxygen, you call it sulfite. But then let's say you want to take another one down. Well, you can't call it sulfite anymore because sulfite's already taken. So you need to add something more to indicate that you've lost 1 more oxygen. So you keep the "ite" to indicate that you've lost the first oxygen, and then you add hypo to indicate that you've lost another one. Does that make sense? And per is just to indicate that you've added 1 more, and you keep the 8 because it's already, that has been established as the reference. Okay, and you don't go past per and you don't go past hypo. You can't have less or more than that. Okay.
Okay, cool. So knowing that, what would we call that?
Perchlorate.
Perchlorate.
No, not
Perchlorate.
carbonate. Yeah, not carbonate, because remember carbonate is Ca. Yeah, just clearing that up. I also recommend, what makes this easier is also know the names of the elements, because I know some of them can get confusing. Like I've had students confuse sodium with S. So sodium is Na, just remember that. Yeah, there's other ones that they've confused. But yeah, just make sure you memorize, for starters, just the names of the elements. I recommend watching that little periodic table song. It's catchy, and I mean, it helps memorize it. But yeah, you for sure know the symbols of these, for starters. But yeah, so perchlorate. So yeah, we see that the ClO4, we see that it's okay, wait, they erased it. Okay. Yeah, that was right though. Perchlorate was right. So let's do another one. What would that one be called?
Sulfite.
Sulfite, yeah.
Yes.
Oops, my bad.
My bad. Okay, there.
Does everybody, I know there's a lot of us, but I do want to make sure everybody's getting it. So does anybody not understand why it's sulfite, or why we named it like that?
No,
I
I'm still
didn't
confused.
understand the
You're still
previous one.
confused? Okay, what's confusing exactly?
Well, I mean, I understand that "ite" is removing oxygens, but like I don't understand how you can get that out of the formula name.
Okay, so you see the SUL, you can tell from there, and the SULF, you can tell right there that it's going to be sulfur. Okay, so you see that it has an oxygen, and you see that it has a charge. So remember what how I said it. If it has an ATE and an or an ITE, it's for sure going to have oxygens and a charge. We don't know how many oxygens The charge depends on the element, on the first element, but when looking at the suffix and you see that it has an ATE or an IT, you know that it's going to have an oxygen and a charge, all right? So looking at it from there, sulfur, you can see the sulfate or you see this SULF, you know that's going to be sulfur. It has an it has an oxygen, so you know it's going to have either one of those suffixes, okay? And then you see it has a charge, so you know it's going to have one of those suffixes because it's a polyatomic oxo anion, okay? So you see that, and that's where you got to remember your reference numbers, yeah. So you saw that it was sulfur. You remember, well, okay, it's not part of the rule of 7 because that doesn't look like it's part of that little 7 that formed. So you assume that it's 4. Okay, so you look at SO4 and then you see its charge, you see it's -2. So you see that its reference number is 4, so that's what is used to call it sulfate. Okay, so, but you see it's SO3 -2, so you know it's lost 1. So that's where you use the ITE. Does that make sense? Hopefully I'm not, hopefully if other peer leaders, if I'm explaining it too confusingly, just let me know, or if I'm not doing my best. But yeah, did that make sense,
Okay.
Omar?
Let me try this one.
Yeah, can you try?
Okay, so if you have an element that's on the outside of the 7, as we said, so let's take sulfate. That sul kind of sounds like sulfur, right?
Yeah.
So then we had to determine where sulfur is on the periodic table. Is it on the 7 or is it inside of the 7? Because it's inside of the 7, that means the reference oxygen is going to be 4. And remember, since it's a 8, the reference oxygen doesn't change. So literally all you do is just put the S in there and then add the charge.
No, but the problem was SO3. That's also why he was asking why.
Oh, okay.
Yeah.
So same thing for ites. Remember that ite is -1 from the reference. So 4 minus 1 would be 3. And then if it's hypoite, remember it's 2. So 4 minus 2 would be that. So just remember, where it is placed on the periodic table, if it's on the 7 or if it's inside the 7, that's how you find out your reference.
And is it only going to be those 7 elements?
Well, no, the 7 and the 4 right there, and then the 4. So it's 11 in elements in total. Those are the ones that you're going to see that have an oxo anion. Okay. There's another one called permanganate, but I mean that one I think is in your table in the workbook that you should memorize. But yeah, and then manganate, is chromate. Also, you have chromate. Those are
remember that the rule of 7 only does up to like about 90% of polyatomic ions. It's up to you guys to remember the other 10%. So stuff like that, or whatever the other ones.
Yeah, so usually you won't see like just to let you guys know, you won't like acetine, that AT at the bottom below iodine. You usually don't see that in your tests a lot. They don't use them. Chromate and permanganate they do use though. I have seen examples of those, so just remember that the charges and how they look. But
that's a very good question in the chat. Sorry to interrupt you, Andre. But the charges have to deal with the elements themselves. So if it's sulfite, nitrite, it deals with the elements. And a quick way to remember, if it's on the 7, it's how far it is away from this oxygen group. So that's -1, this one's -1, -2, -3. If it's inside the 7, then it just retains its normal charge. So sulfur has a normal charge of -2, phosphorus is -3.
Yeah.
So it deals with like that element.
Also looking at this, don't get confused though, because the charge of nitrogen isn't -1, but like if you were to have nitrogen separately, like not part of a polyatomic oxo anion, it is not -1. Does that make sense? You know what I'm trying to say, Jonathan, actually? Because I have had also confusions with that. Some people might think that the charge of nitrogen is -1. No, not in this case. It's only in the polyatomic oxoanions case. So when we're doing the whole 8 thing. So you know what I mean? Does everybody? Yeah, only in polyatomic oxoanions.
So yeah, this only works for the rule of 7, nitrate, nitrite, carbonate, carbonite, all that type of stuff. So everything it's like carbonate, carbonite, or hypochlorate, hypochlorite, they're always only going to have a charge of -1.
Yeah.
Cool. So we spent an hour on module 2. We should probably move on because I know there's other things that we need to explain. We can't spend all our time on naming like nomenclature. So if you guys have any more questions, we can save it till the end. Right now, I think I want to move on. So I saw a lot of things about conversions.
They're asking about acids.
They're asking about acids.
I feel like nomenclatures.
Right,
I feel like nomenclatures where everybody's gonna need the most help on.
Yeah.
Oh damn!
Well, acids are pretty easy.
Except for you, maybe not for them.
Yeah.
I ate a horrendous. Hey! I came here to review with my students. I'm here to get bullied.
I did too.
I ate a horrendous bite. Just remember that. So if it's an 8, it has an ick. If it's an I ending, it's an us. So what's that acid? Well, it'd be
chloric acid.
Acid. Yes, perfect. Chloric acid, because it's an chlorate ion with that H.
But also remember there's another type of acid that doesn't have the O's.
What if you had this?
So if it doesn't have the O, we're not the same thing.
So what if you had this? What's the difference between this one and that one? What would you call this one?
What the hell?
Hydro. Okay, not chloride, because we use the acids is an acid because this is an acid as well. So for acids we do use these suffixes. So it would be hydrochloric acid. I don't. Okay. Yeah. Oh my God.
We put the suffix "ic" as well, but for this one.
Monoatomic acids, if I'm doing it correctly. And there's also like let's do one more example. What would this be called? This one right here, the HBr, hydrobromic. Okay. Yeah, when there's no oxygen, when it's not like there's no oxygen, we don't call it hydro. You don't use hydro. You just would call it bromic acid. Okay.
A good way to also remember when to use hydro and when to not. If it's monoatomic, meaning that it's only one element, you use hydro. If it's a polyatomic, which means there's a compound of more than one element, so that's 2 in this case, you wouldn't use the hydro. So you have to keep that in mind when naming acids.
Yeah. So yeah, these are examples of monoatomic acids, IJ. These are monoatomic. So okay. I see Jonathan's writing an example.
Wait, mono we do hydro, or poly we don't?
Hydro, yeah, mono you do hydro, and poly you do not do hydro. You just write the whatever the element is on that like the prefix for that, and then you just add ic and acid. This is for polyatomic.
How do you know chloric acid and not hydrogen chloride? Oh,
Well, that's a good question. Well,
that is a good
that
question.
goes more into like theory and stuff. So acids will always have the H plus ion when it dissociates. You don't need to worry about that right now.
Nope,
Just
not at all. But yeah, the
remember
H is a
this.
cation. In this situation, the H acts as a cation for a reason, which we don't get into right now because you don't need to know.
That's a Chem 2 question, but I like that spirit.
Yeah, good questions. Okay, cool. Yeah, what do we do next?
Okay, so can anybody tell me what the name of this is?
Sulfurous acid.
Yeah. Perfect. Sulfuric acid.
Nice.
So just remember, ick, I ate a horrendous bite.
And does
There's
everybody
also
get why
another
there's
one.
two hydrogens?
Oh, sorry.
Oh no, you're good. You're good. I just want to make sure. Does everybody get why there's two hydrogens and why there's no like parentheses in the sulfite or in the No.
No, they don't.
Okay, so Jonathan is. Yeah, it's because of the charges. It's basically because of the charges across. Yeah. So remember that.
Okay, remember that sulfite has a 2- charge, and each hydrogen always has a +1 charge when it's ionized. So we need 2 plus charges to cancel out that 2- charge.
Yeah. What else?
So can someone tell me what phosphoric acid is? Let me write that down. Phosphoric acid.
Oh yeah, working backwards.
PO4 with a 3- charge, but with an H in the front with.
Yeah. So if you have the H in the front, what do you do with the charge? Because if you're combining it with a hydrogen ion, what are you gonna do?
H3PO4 with it.
H3PO4. Yeah. Exactly. No,
three.
not. Oh, it's a. What do you mean? The 3, like in the oxygens, or what do you?
Right here.
No, because remember it's called phosphoric. So if it ends in IC, that means that before you combine it with the hydrogen, it was phosphate, and phosphate has a reference number of 4. Okay, phosphorus has a reference number of 4 oxygens, so to be called phosphate. So that's why it's PO4. Okay. Does that make sense? Or yeah, okay. Yeah, remember it's not 3 because 3 is for the rule of the other rule, the boron, carbon, nitrogen, chlorine, and chlorine, bromine, and iodine.
So acids always have a hydrogen first?
Yes.
Yes, they do.
Yeah. Yeah, acids will most commonly have a hydrogen, yeah.
Can we go over what we should know for the theories being asked on the exam?
Oh, okay. I think I know what they mean. So you're talking about the Dalton's theory. That's the conservation of matter. That's one that I think I saw Dr. Alexander stress. So conservation of matter. This is one that I saw him stress a lot. So we're going to go over that. What is the conservation of matter? Can anybody tell me?
Wait, what does that first word say?
Oh, conservation.
Okay.
Well, basically that I'm sorry. Don't judge my handwriting.
Yeah, stop bullying Jonathan, guys.
Okay, so basically conservation of matter is if you start with something, then you have to end with the same things. Right? So oh, there was a good example. Give me a moment. No, that's not a good example. Okay. Basically standard reaction that you'll see, probably HCl plus NaOH. Basically what the conservation of matter is that if we have one H, one Cl, one Na, and one OH, we also need to have this on the other side, right? So basically balancing equations, yeah.
But is that part of what's going to be on the test though? I thought this is more than that. I don't think this is part of module 2.
It's one of the things that Dr. Alexander stressed, and
yeah,
I did
he
see it.
usually goes over a lot of definitions, and whatever he puts on the questions, that's how it's going to be shown on the exam. So I would just kind of really memorize them, but also understand them, because whatever he puts on the study questions is exactly how it is on the exam.
Yeah, so just one of these, and I think one of the things that you do have to remember is this conservation of matter. Yeah, basically, if you've seen it in lecture, you're going to see it in the test. So I don't know, this is basically the conservation of matter. If you have it on one side, then you have to have it on the other. Yes, yeah. So there's something that okay, so basically CaOH2, remember that we have two OHs on this side, and you're basically going to have to use ratios by multiplying stuff on both sides to be able to, I guess, balance everything out. And really it's just practice, and it's really just practice, and it's just trial and error once you do it on the exam. But so there's nothing we can really teach you other than just like really just remember what conservation of matter is and the definition. Okay, again, remember that these laws, it's easier if you just remember the definition and then apply those definitions. But basically definite proportions are kind of the same thing. It goes on to, it's ratios all over again, right? So just remember that definite proportions, again, the proportion is that ratio. So my best bet is, instead of us explaining it, you should just remember the definition and be able to apply that. Does that make sense?
What's going on?
Okay, is there anything else that we want to cover?
Does everybody feel confident on nomenclature though, on naming all that stuff? Yeah.
Okay.
All right, what about
Empirical formula? Oh, that's not going to be on the test.
yeah, that should
Yeah, we'll go over that next review period. That's not going to be on the test. So don't worry.
Balancing's not going to be on the test either?
No.
Let me double check their study questions though.
Yeah, because
just
I can explain it real quick. So the difference between empirical formula and molecular formulas is that's glucose. So that's glucose. And so that is the molecular formula, C6H12O6. But empirical formulas basically have to do stuff with ratios. So if you'll see, this is the empirical formula of glucose. And the way we get it to that glucose is multiplying it by 6. So basically, this is empirical, and then this one's the molecular.
Yeah.
Yeah, basically just simplifying it.
Okay, I saw a question right now though. So sulfate is not balanced. That's why we add the hydrogen. So yeah, basically ions, what they are unstable. They're not. They have a charge. So what they want to is to balance that charge. They want to be stable. That's what every ion wants to do. So yeah, sulfate, like I said. Yeah, was it sulfate that you mentioned?
Yeah, it was sulfate.
I can't write. Okay, yeah, no, I can't. Okay, so sulfate. So yeah, the SO4 -2. So yeah, like I said, think of this as one whole thing. Like it's an ion. It's one ion, but it's made out of many atoms, or well, just 2 atoms. But think of this as one thing. So yeah, what it's trying to do, it's trying to balance. So when it gets put with the hydrogen ion, when you add them together, you just get the H2SO4, and that's when it becomes an acid. So yeah, that's what you're trying to do, is get the charges to not be there anymore and to equal to 0. 0, yeah. I don't know if that answered your question. So yeah, but yeah, the sulfate is not balanced. It's not stable, is what we want to call it, right? So yeah.
On their study questions, there is some questions about empirical and molecular, and then balancing equations as well. So we should go over it with them a little bit.
Okay, cool. Let's do the other one that we had. HCl plus. Can anybody name this? Remember, this is this one. Remember, this part is actually a polyatomic ion, so you do want to remember that. Calcium hydroxide. And then remember how I got that. Calcium has a 2+ charge, and then the hydroxide ion has a -1 charge. That's why we have 2. And remember, it's all about balancing that, the charges there. So when you balance that equation, basically we do just a switch between those. So we'll get CaCl plus HOH. But remember that we have to have equal numbers on both sides and equal charges. So is that a correct representation of calcium chloride? No. Okay, so what do we have to do to that? (2Cl), perfect. And then do we have the same amount of things on each side? To Michelle's question, there's different types of reactions. So it really just depends on what type of reaction you're doing. But in this case, you can kind of just remember it as that. So this is a double replacement because we have 2 replacements. But you'll get into that later on. So just remember that you kind of just do switch those 2.
Well, I mean, but what if they get a problem where, like, I don't know, like let's say you switch out the calcium for sodium, and then for, I don't know, and then the hydrochloric acid for something else. Like, should we teach them like that rule that it's like the salt and plus the water, or? Because I feel like that's why I don't like that he's having those types of problems already, because I feel like it's more modular.
I think he'll just give you what I think Dr. Alexander will do, and what's most likely he'll do, because you guys are barely on module 1, is he'll give you this equation, and basically he'll say, okay, do the law of conservation of mass. And so this is what we're going on to our next step, is basically we're going to be looking at balancing the ratios between each of these. So that's what I imagine that he'll do more likely than just saying, combine HCl and calcium hydroxide. What I believe will be on his exam will just be something like this and say, what are the ratios? Or what are the coefficients?
He's not gonna put he's not gonna make do a whole word problem because he won't do that. He won't do that. I know that for sure.
A good way for when you're balancing equations to keep track of what you have is to do this, like do all the elements on the right and all the elements on the left and like write them out. So like, you know that on the left you have 1 hydrogen, 1 chlorine, 1 calcium, and 2 hydroxides. Oh, I didn't mean to put 20. And then you do the same thing on the other side. So can you guys tell me how many of each is on there?
Guys,
Okay,
just
good.
please unmute yourself. It's a, oh, never mind.
So it's 1 hydrogen, 2 chlorines, 1 calcium, and 1 hydroxide. And I like to do them like in the same order so it's easier to see if your numbers match. And obviously here your numbers don't match everywhere. So you have to find out like what coefficients you're gonna put where, so like that both of your numbers match.
Oh, wait, there's a 0 on the, is that a 0 on the, on the hydroxide? Yeah, there needs to be 1 there.
I mean, you could write it as H2O because technically it is, or so it could be easier when balancing the equations, you know, because then you could be like, oh, this is an OH. But yeah, this is written as H2O, and there's 2 hydroxides. I mean, hydroxides. There's 2 hydrogens, guys. But over here, because of the hydroxide, so that's why there is 1. But just so you guys won't get confused on that. There you go.
And then this you guys should be able to do because this is just conservation of mass, which is why I talked about that a little bit.
So here you have 2 chlorines, but on this side you only have 1. So what would you have to do to this side to get there to be 2 chlorines?
Multiply it by 2.
Okay, and then whatever you do to the chlorine, since it's bonded with the hydrogen, you're gonna have to do to both. So you're gonna have to multiply it by 2. But now you have only 1 hydrogen here. So what would you do to this hydrogen?
You would multiply it by 2.
And then you have 2 hydroxides. What would you do to the hydroxide to get it there to be 2? By 2, yes, good job. So now everything looks pretty balanced. So since you multiplied the hydrogen and the chlorine by 2, you put the coefficient, right? The coefficient of 2. And then you didn't do anything to the calcium or anything to the hydroxide on this one. So these can be left alone. On this side, you didn't do anything to the calcium or the chlorine. So these can be left alone as well. And here you multiplied both the hydrogen and the oxygen by 2. So you can just put your 2 right here. Now, does it look balanced to you guys?
I don't understand why when you multiply the calcium, you multiply the hydrogen as well.
Oh, I meant chlorine, sorry. But it's because the chlorine and the hydrogen are bonded together on this side. I didn't do anything to the calcium, I just said calcium, my bad. But yes, so since hydrogen and chlorine are bonded together, you're gonna have to do the same exact thing to keep up with the law of conservation of matter. Does that make sense?
Yeah, that makes sense now.
Sorry about that. And good job, Jose. The ratio would be 2, 1, 1, 2. So you guys have to keep in mind those ratios. do you guys feel like you guys need more help with balancing equations, or do you guys kind of have it? How are you guys feeling about it?
Also, dimensional analysis, if anyone has with that.
If we're all good here, we can move on. Basically, that's what they're saying.
No questions.
All right, let's move on.
Gucci.
Okay, you guys want to do conversions right now? Or dimensional analysis? What do you guys want to do?
Yes.
Any.
All right, conversions. That's what we see.
Everything.
We can't do everything because, again, we have a limited amount of time.
Dimensional analysis too.
By any chance, have you guys seen the videos on the YouTube Peer Leader channel? Did you guys know we have a YouTube Peer Leader channel? Okay, perfect.
Who don't have them, I'll go ahead and ask, or yeah, we'll make sure you guys.
Yeah, I can link it right now. I can find it real quick. But let me try sharing my screen. Okay, cool. Can you guys hear my voice twice or no?
No, I don't.
Okay, well, I'm going to talk with my earphones off because I hear it far. Okay, so basically what we have here is the SI prefixes. And what these prefixes are, they're multipliers. So when we have basically this kilometers, we multiply meters by however many kilometers are. Okay, so basically when we say how many meters in a kilometer, does anybody know how many meters in a kilometer? 1,000, perfect. And we can see on this table that the kilo multiplier actually means 1 times 10 to the 3 or 1,000. So basically you have to use this table, and I guess you have to memorize this table before you can actually do conversions. And I actually have a really cool way to memorize the table. Going up this way is kilo, mega, giga, tera. But a quick way you can remember this is kill my gamer tag. Or keep my gamer tag.
No, my gamer
and then
tag.
going down is that's during cookie making. You need pictures. So shout out to one of my students who helped me create this. So the way you remember this is going up, you multiply it by a factor of 3. So that's 1 times 10 to the 3rd, 1 times 10 to the 6th, 1 times 10 to the 9th, and 1 times 10 to the 12th. And then going down is -1, -2, -3, -6, and then it's the same pattern as that. So 6, 9, 12. Okay, does everybody understand that?
During cookie making, need pictures?
Yes. During cookie making, you need pictures. And this one is kill my gamer tag. Or keep my gamer tag. And so remember, you can't have anything before you start the test, but after you basically start the test, you're free to write this in your scratch sheet of paper. That's fine and dandy. So I suggest making this table before you actually start anything. Oh, that's weird, that's weird, that's weird. Make sense?
I have a question. On the exam, I think the professor told us that, like, on a metric system question, like yards or feet, he was gonna give us the, like, just that part, and then we'd have to do the SI part. Do you know what I mean?
But remember that when switching between metric and customary, that transition isn't nice. So that's why he'll give it to you. So he'll give you the yards to kilometers, but he won't give you like meters to kilometers, if that makes sense.
Yeah.
Yeah, perfect. That's what I meant. Thank you.
So if it comes to those like inches to centimeters, for example, you guys will most likely be given that. It's just conversions between these scientific, the SI units that you guys will have to remember. Okay, should we start on an example? Okay, cool.
What type of example? What are we doing now?
Still conversions.
Oh, okay.
I'm sorry, I'm a little excited because we did this during office hours today. So basically 100 kilometers to centimeters. Quick way to remember this is I have a couple steps. Number one, write down what you know. So one, we know that we have, of course, 100 kilometers, and we know that we want to get from kilometers to centimeters. Pretty standard stuff. Number two, then we write down our conversions. So we know that we have to use kilometers to meters and meters to centimeters. And I want to say that do not skip steps. You cannot do kilometers straight to centimeters. Because if you do, then you can't use the table. So notice how I have meters here, and that enables me to use whatever's on that table. So always, always, always have that conversion to that reference. Does that make sense? After that, we just fill in what we know, and then dimensional analysis, that bad boy. Do you guys want me to go over this example, or do you guys?
I think you should. Yeah, you should do the
I think
dimension.
you should go for the example. So
Right,
that way you'll see where to put if you put the negative or not, you know?
Oh, yeah.
Okay. Oh, that's
For sure on
okay.
that one.
Yes.
Yeah, because people get confused on that.
So 1 kilometer is equal to how many meters?
10 to the third.
1 times 10 to the third. Perfect. And how many centimeters in 1 meter?
-10 to the -2.
10 to the 1 times 10 to the -2. Perfect. But there's a special thing. 10 to the 2. There's a special thing when you use this method, and this method is making the bigger one equal to 1. So if you see that kilometers is bigger than meters, and so I immediately made that 1. And meters is bigger than centimeters, so I made that 1. If you have that, then you can just drop that -2. So if the bigger unit is equal to 1, then you don't have to worry about the exponents. Is that clear? It only works if the bigger one is equal to 1. So notice here, I just have 2 instead of -2. Does that make sense to everybody? Okay, can you guys see my screen? Is that fine?
Yeah, you're good.
All right, perfect. Okay, so then we just do dimensional analysis, and this is where this part comes in. So we write down what we have, which is 100 kilometers. Then we do the fence method, and then we look at our conversions, right? So on this conversion, we have kilometers. So which conversion am I supposed to use? Number 1 or number 2?
1.
1, perfect. Because it has the kilometers and we want to cancel that out. So where would kilometers go, on the top or on the bottom?
Bottom.
Bottom, perfect. Why do we want to put it on the bottom?
So it cancels out and converts to meters.
Perfect, perfect. And then after that, it's just simply plugging it in. Same thing here, we already used this conversion, so cross that out, and we only have 1 more. Meters, centimeters. And here it's 1 over 1 times 10 to the second. And so all of this is basically, you just cross multiply that bad boy. So just plug that into your calculator and tell me what you guys get. Sounds about right. Yep, 10 million. Can you actually convert, let's see this.
Scientific notation.
Marco, convert that into scientific notation, please. Yeah, so typically in these big numbers, you just want to keep it as scientific notation. It makes your life so much easier. One times 10 to the 7th. Perfect. So that's basically how you did the conversion. You just write it down and then write down your conversions. But when it comes to writing down your conversions, always, always, always make sure you have that reference unit in that conversion. Do you guys want me to go over one more? All right. All right, I'm making these off the top of my head, so you guys are gonna have to bear with me. 7.2 teragrams to how many megagrams? So what's our first step?
Write down what we know.
Perfect, write down what we know. Okay, I got you. I'll get to that in a moment, Clay. So what do we know? We know that we have 7.2 teragrams, and we want to convert from teragrams to megagrams. Pretty simple. Step number 2, write down our conversions. So teragrams, always, always, always put grams. Ooh, how come nobody told me? So always, always, always put teragrams, megagrams. Okay, sorry about that. But always put your reference unit And so from the reference unit, we go to megagrams. Can someone tell me that conversion for the first part?
10 to the 12.
10 to the 12. Where do I put 10 to the 12?
Next to the grams.
Okay, why do I put it next to the gram?
Because there's 10 to the 12th gram. That's the same amount as 1 teragram.
Perfect, perfect. So 1 teragram, and you put the 1 right next to the bigger. Next to the bigger one. So can someone tell me the next conversion?
One times 1 to the 3rd milligrams. For the milligrams, not grams.
Oh, this is not milligrams. This is megagrams.
Oh,
Remember,
mega?
capital M. Capital
M.
M.
Then 10 to the 6th.
Where do I put it? Where do I put it? On the left or on the right?
On the right.
On the right?
Oh, wait. Yeah, left, sorry.
Okay. So 1 times 10 to the 6th. And remember, you always want the bigger unit 1. So after that, we just dimensional analysis this one. And to answer,
Wait, I'm not understanding how you guys are getting those numbers.
Okay. Remember that chart that we did earlier? So keep my gamer tag. Yeah. So that's +3, +6, +9, and then +12. So this is all in reference to G, right? So when we do teragrams, we see teragrams is equal to +12.
Mm-hmm.
And you can see that we put the 12 here. And then we can see, oh yes, it is in page 40 of the Chem workbook, if you want to see that. But if you see megagrams here, we have a +6 over here. You see that?
Oh, okay.
Okay. Yeah, and that's why this is pretty important to write down the conversion table before you start the exam. Okay, so everybody gets where we got this? If not, just unmute yourself and tell me. All right, anyways, we got 7.2 teragrams, which, let me write it down here. 7.2 teragrams.
To 6.
Wait, say that again?
Wouldn't you
Wait,
go
say that
from,
again?
yeah, wouldn't you go from 12 to 9 to 6?
12 to 9
From
to 6?
tera to giga to mega?
No, because remember the chart is always based on this reference value. So that's why we always have this G here.
Oh,
Right?
okay.
So the chart only works if you have one of these things as the reference. So your references are grams, liters, and meters. Does that make sense? You always have to have one of these in your conversion.
Yes, no, but my question is, in the conversion, like in the so like in this next part, you would put 1 times 10 to the 12th, right? On the numerator.
Yeah.
Right?
Okay, yeah, perfect. Why do I put it in the numerator?
But then you would go to the 9th, no? You would go to giga after that.
Well, we don't need to go to giga because we have our conversion ratios here, right? So we see we converted this into grams and then we converted these grams straight to mega. So we don't need to use any of those other steps.
Okay.
In other words, I see where you're coming from. So 1 teragram is equal to 1 times 10 to the 12 grams. And then 1 gigagram is equal to 1 times 10 to the 9, again, grams. So that's why we always have to use these grams in our conversion ratios.
Right.
Does that make sense? Okay, and then 1 teragram. And then we really just fill out our equation here. So 1 times 10 to the 6 grams equals to 1 megagram. And to answer Clay's question on how this actually works, really remember that this is just a whole bunch of fractions. But we don't like writing fractions because it gets messy pretty easily. So remember that instead of when you multiply this straight across, which is what we do when we input it into the calculator, we'll have, we'll just use X for now. X teragrams, grams, megagrams over teragrams, grams. And if you can see, we just cancel out because we have them on both sides of the fraction, leaving us only with megagrams. It's just that the fence method is a little bit cleaner in my opinion, because you don't have to worry about all this. Does that make sense on how this fence method actually works? Okay, perfect. So when you do this, what do you guys get? Okay, perfect question. Why does it go on the bottom? Remember that's 1 times 10 to the 6 grams. Remember that we want to have whatever we have currently on the opposite side of the fraction. So when you do this, since we have teragrams on the top, then we want teragrams on the bottom. But since we have grams on the top here, let me do this in another color. Because we have grams on the top here, we want to cancel out these grams by putting it on the bottom. And so we put grams on the bottom and then megagrams on the top. Does that make sense? I think it was Michelle. Does that make sense? Perfect. So I'm actually getting 7.2 times 10 to the 6. Is that what you guys are getting? For Elizabeth, just make sure that you're putting, you're doing the, I guess, putting it into your calculator, correct? Oh, okay, yeah. So the way you'd input this into your calculator is you put 7.2, and then if the number that is not 1 is on the top, you multiply it. If it's on the bottom, you divide it. So you'll look something like 7.2 times 1 times 10 to the 12 divided by 1 times 10 to the 6, right? So that's a quick way to do it. Because remember, this is just, you're just multiplying fractions. Or you can use the fractions if it makes it easier. But just a quick way to remember it, if it's on top, then you multiply it. If it's on the bottom, then you divide it. Does that make sense, Clay? All right, perfect. All right, I think that's enough with conversions for now, unless you guys want another one. I'm sorry, I kind of took off the spotlight. Yeah, sure. Go ahead.
How do you know to like convert it? And not just this one, just like generally, because you converted teragrams to grams, you converted kilometers to meters. How do you know you need to convert it to like to meters and not like feet or milliliters or, you know, all that, if that makes sense?
Okay, yeah, that makes sense. So typically, there's a couple things. As you go on into chemistry, you're going to realize that some things are just going to be given in a different unit than they actually are. So if you remember density, what is density? Well, density is grams over milliliters, right? And we know that we need milliliters on the bottom, but sometimes they'll give it to us in liters. So that's how we know we're going to have to convert from liters to milliliters. But in terms of your test, it's what most likely will happen, and it's just going to be giving you something like that. Convert teragrams to megagrams. That's how you're going to see it most likely on your exam. Does that make sense? I hope I answered your question.
Yeah, I'm starting to get it.
Okay. Also, yes to Raquel, but also we don't really use customary, so we're not going to be using our yards, our feet, our inches. We don't really use that in chemistry. It's mainly going to be just our grams, meters, liters.
Okay, thank you.
Okay, I see that you guys want one more. Actually, we have 10 minutes. I think if you have any more help or you need any more help, I have videos, and I personally did the videos that's on the YouTube website. So you guys can just watch that, and I'll post the link up right now. But we only have 10 more minutes, so I want to cover as much as other things as you need.
So ended at 6:30, or because I don't think Lester said in the preview meeting that it could last longer, but I don't know.
Personally, I have to leave at 6:30, so that's my marker. If you guys can stay, then
Same here.
Okay. Well, yeah. Yeah. Okay. All right.
So is there anything else that you have to do or that you have questions on?
Could we go over the group charges real quick again?
Group charges, okay.
Oh, the group charges. Like what? Like the nomenclature, or like the? Oh.
No, like group 1 had the charge of +1, right?
Oh yeah.
Yes. Yes.
Okay, so basically the explanation for that, or what?
Well, I just wanted to know the charges.
Okay, so for group 1, it's +1. For group 2, it's +2. Then you skip all your transition metals, and then it's +3 for boron and downward. So for that column, ±4 for carbon and downward for that group, and then -3, -2, 1. So the reasoning behind that, like, I mean, you can memorize them, which I do recommend, but just the reasoning behind that is like, so if you can see your noble gases, like they're all stable. Those gases at the end, they all have a charge of 0. So basically what elements want to do when they're when they become ions, they just they want to have a stable shell. I don't know, I know he hasn't gone really over atomic structure that much, but what it's just saying, it's to become stable, the charge means just how many electrons it can lose or gain, just to get that stability, like the noble gases. Does that make sense?
Yeah.
Or, yeah. Okay. Yeah. That's the whole reasoning for the charges. But that's why, yeah, when they're ions, that's why that's the common charge, like -1, -2,
and then group 4 is it can give or take.
Yeah. So like if you look at fluorine, for example, fluorine, the reason why the charge is -1 for that is because I don't know if he's gone over valence electrons yet. But basically in an atom, just each shell has a different certain number of electrons that it can have. So in the first one, it can only have 2, and then after that, it's 8. So if you see that fluorine is, I think, it's 9, it's number 9. So that also means the number of electrons it has. So if you see fluorine has 9, so it has 7 valence electrons. So it's easier to just gain 1 more electron to become stable. So it can have 8, which is a stable shell. So that's why it's -1, okay?
Okay.
And so on for the other one. So like oxygen has 6 valence electrons, so it's easier for it to gain 2 electrons than to lose 6 to have a full shell. Does that make sense? You'll see more about this later on, but for now you can just memorize them. Yeah, group 1 is +1, group 2 is +2, And then you skip all the transition metals, and it's +3, ±4, -3, -2, -1. Okay. Yeah, you'll have to remember the charges right now. I'm basically giving like the long explanation as to why they are. You'll learn about that later on anyways, but yeah, for now I just recommend memorizing them anyway. But yeah, I don't know. What else is there? What else are we doing? I feel like Jonathan had the whole dimensional analysis part down. I feel like he's the best one at that. I prefer to explain nomenclature. So yeah, I don't know about you, Andrea, but like, I mean, if we're gonna extend, like, I could stay a little while after if anybody still has questions, but just, yeah, I feel like I'm better at explaining the nomenclature first. So if you still have questions about nomenclature, module 2, which is basically module 2, I can still stay for that. But yeah, module 1, I can still help with module 1, but I just feel like I'm better at explaining it for you guys, just to let you guys know.
One more thing, if you guys are going to hop off, I did make a little worksheet, like, you know, little extra practice. If you guys get the worksheet down, then you guys should have, or you should do fairly decently on the test. Remember, this is all just extra practice. So
you don't have to do it, but it would help you guys in the long run.
Yes.
Yeah, that's for those people asking for more help. So there it is.
Yeah, for those of you who are in my workshop, I'll also post some more problems for you guys, especially because I know in my workshop we didn't really cover dimensional analysis that much because we didn't have time. So I'll post some extra problems also for you guys, and I'll post the work as well for anybody who's in my workshop. All right. Does anybody have any questions? Or are you guys going to leave you and Claudia, Jonathan, or what's up?
I think I can stay a little longer if you guys have questions. I don't want to just leave off. But, I mean.
I'm actually going to go at 6:30 because I have a lot of stuff. So, yeah. You know, I think I'm good.
All right. All right, so if anybody has any questions, you can ask them right now. Actually, like, we're not ending, but you can leave if you want, because I know it's been I feel like everybody's been here for a minute, but yeah.
I will stop the recording now, so